Hi, my name is John. Welcome to another Wednesday catch-up video. In today's video I do a repair for work. It's a screw cutting job on a CV joint with a really badly damaged thread. I'll show a little bit of that. Then I put another one of the lathe tutorials up. This one is all about tailstock alignment, which is a really important subject. I hope you get something from that. I did mention on Sunday that I'm going away to a steam rally. This weekend I'll be at Onslow Park. You'll probably find me on the Sentinel Drivers Club stand most of the weekend. Then the weekend after that I'm going to Scampston, and I'll just be sort of floating about at Scampston. Hopefully I'll get dirty. My friend Derek will be there with his little Fowler traction engine, so I'll have a bit of play with that. This is a drive shaft end or a CV joint. You don't need to be an engineer to decide what's the matter with it. The threads are knackered. What's happened is it's picked up on the way off, picked the threads up. It happens quite often on them. That's the nut, and I'll have to actually cut the nut off to get it apart. We can't get one, at least we can't get one in a hurry. The thread's 24mm. I could machine it down, weld it up and rethread it to 24mm. But all I'm going to do is machine the threads off next side down, which is 22mm. I've got a 22 by 1.5mm nut that'll screw on there, and that's still going to be plenty strong enough to do what it's got to do. The centre in the end is also damaged, so the first thing I'm going to do is drill a new centre, then we can support it at this end, then machine the threads off. All I have to do is push it straight. Looks pretty good there. Right, so that's the centre recovered. There's that twice cut once, as the old saying. Right, that's a down to size. Right, now it's just setting up a screw cutting tool, setting the gearbox up and screw cutting it. But before that I'm going to put a little countersink in there, a little chamfer in there for my screw cutting tool to drop into. So I don't want a square shoulder in there, because square shoulders can cause issues. You need a nice sort of radius in there. So a radius like that is stronger than a square shoulder. That will stop the, stop it forming a stress point. This is a commercial cutting insert 1.5. Make sure it's square to the job like that. I know it is on centre height because I use it all the time. So we gently touch this off like that. We'll put some cut on. On a metric thread I can disengage the half nuts, which makes it a little bit easier. Just going to make sure that we are putting a 1.5mm pitch before we get too excited. We're looking for 1.5, and that is bang on the money, 1.5. That's better. Right, we'll settle for that. Definitely. And that's the nut I want to use because that's what nail up in it. Right, happy with that. Hi, my name's John. Welcome to part 17 in a series of short videos all about the metalworking lathe. In this episode, or this instalment, I'm going to discuss tailstock alignment, how to get tailstock aligned with a headstock so you can do parallel turning. I did a taper turning video the other week and the lathe is still set up for taper turning, so I've got to get the tailstock aligned, and now's a good time to do a little bit of video. That's enough talking. We'll bring the camera in and so we can get things straightened up. This is looking straight down at the centres on the lathe, and you can see it's a mile across to one side because we're doing a taper turning job with it. So we've got to move it back into line with that front centre. There's actually a scribe mark on here which lines up with the scribe mark when it is lined up, and that gets you reasonably accurate but not accurate enough. It's adjustable by two cap head bolts, one that side and one that side, which push against a central position, and this moves back and forward on some dovetails. The big clamp handle is the thing that stops it moving. So obviously it's a mile this way because we were doing some taper turning, so it needs to go across that way. So to make it go across that way, we loosen this one off. Quite a long way. And we'll tighten this one up, and that pushes the tailstock away from me back into position. So once they're lined up, that gets you roughly in the ballpark, and then we can do some measurement to make sure that it is absolutely right. Right, so that is fairly near, or as near as I can eyeball. A little touch more, I think. Right, that looks good. To get a little bit more accurate, put a steel rule in there. And if you push a steel rule gently with the tailstock, you can see it's at an angle, so we need to come slightly more this way to straighten it up. Try it again. Still at an angle. Right, we're going the wrong way because it's getting worse. Right, we'll try it again. Very slightly towards me it needs to come. That's not bad. Very, very slightly more. Right, that's pretty good. If anything, we've gone too far this way. We'll put a dial gauge on it now and so we can get it a little bit more accurate than that. I've got a piece of ground bar here. I'm not quite sure it was off. I got one or two given. It's got really accurate centres on both ends, and I'm going to use this as a test piece. So we'll put it into that centre and then bring a tailstock centre in. Just a little nip on it. Touch a dial gauge onto it and set to 0. And if I revolve that and it doesn't move, it's showing dead 0 because that centre was turned in this lathe. There's nothing else but in line. Up to the tailstock end. Right, we need to move these Allen keys now to get that to 0. Wrong way. Right, we'll try it again. Set to 0. Right, and that's pretty good. This is the final method I use to line things up. I've got a bit of mild seal bar here. It's been centre drilled in both ends. I'm going to mount it between centres. That's going to go in there. Now, I'm not going to use a live centre at this end. I'm going to use a dead centre. That is a centre that doesn't rotate, just to remove any inaccuracy at all from the lathe centre. It's only a little bit of high temperature grease in the end of there. This is the way it was done before they had all these cheap imported live centres. Right, just a little nip to consolidate things, and then I'm just going to put some tape on there to stop it rattling about. All it takes. I'm not intending going in reverse, so this will be alright. Right, so we've got that mounted between centres. We're not concerned about this part because that was machined in a chuck. What we're going to do is take a light cut off there and don't adjust the tool and take a light cut off there and then measure the difference between both ends, and that is a really accurate way of setting it up. So that journal and that journal need to be made out at the same size. A little bit slower than that, just get a little bit of vibration. That's better. We'll work for a minute or two just to let this tailstock centre wear in. Right, I'm going to take a light cut from this end. Doesn't matter what size this is, as long as it's the same size at both ends. Down to this end. Right, so we need to measure those two ends, and roughly are going to be the same size. Right, it's 0.2 bigger at this end, so we need to bring this towards me and do it again, keep on doing the same test. Right, we'll take another light cut, making sure that centre's alright, watching for excess heat. Bastard, clumsy twat. Right, a light cut from this end again. Doesn't need much, just enough to remove a little bit of metal. You can keep this tool and use it over and over again. Right, once again, measuring time. That's dead nuts on there, perhaps. I'll do it with an imperial micrometer. Funny when I start getting down to thousands, I like me imperial micrometer. Piss off. Perhaps a couple of tenths smaller at this end. Let's see if I can tweak it just a little bit. That's absolutely dead on. There's one more check we can do. And I've touched the clock gauge off on there. Obviously it's running dead wrong because I've just machined it. If I wind that into a 0, which is there, and take it to the other end of the bar, absolutely dead on 0 there as well. Of course that's wrong as well. I mentioned that you can take things out between centres and put them back in where you can't with a chuck without having to set it up again. So you take it out, go away and do something with it, put it back in again. There you are, running exactly the same place. So turning between centres is used quite a lot, especially offset turn for the likes of crankshafts. But this is one good way of making sure your lathe's running true. A longer bar would give you even more accuracy. But when you're turning a long part, just measure it in 2 or 3 places. It'll tell you straight away if your lathe is turning true. Once again, just in to say thanks for watching, thanks for subscribing. A massive thanks as usual for all the well wishes, kind words that have come in. It's made a massive difference, it really has. Anyway, thanks for watching.